Hi friends, welcome to our YouTube channel Knowledge Academy. The meaning of this lecture is to discuss about the synchronized systems UPSC prelims questions in a very detailed manner. If you like the content of our channel, then please do like, share and subscribe our YouTube channel and don't forget to press the bell icon button. So whenever I upload a new video, the direct notification comes to your mobile. If any improvement is needed in our video lectures, then please do comment in the comment section. We will definitely include all those improvements in the coming lectures. So why do waste more time? So let's get started. So now we are going to solve the 11th question. See the question here. Which of the following characteristics of the system are defined by y of t is equal to x of t into cos of 100 pi t? So we need to figure out it is a linear, it is a time invariant, it is a stable system, it is a memoryless. Select the correct answer using the given below. Select the correct answer using the code given below. So out of the four options, not even one option is correct. So let's solve this numerical. The first property which you are going to check is the linearity property. So for a system, the input is x of t and the output is y of t is equal to x of t into cos of 100 pi t. So now we are going to check about linearity property. Suppose for the system, if the input is x1 of t, the output which you are going to get is y1 of t is equal to x1 of t into cos of 100 pi t. And for the same system, if the input is x2 of t, then the output is y2 of t is equal to x2 of t into cos of 100 pi t. Similarly, for the same system, if the input is x3 of t, then the output is y3 of t is equal to x3 of t into cos of 100 pi t. Suppose if the input is the summation of the two previous inputs, which is x1 of t plus x2 of t, so in place of x3 of t, I need to substitute here x1 of t plus x2 of t, and if I do the cross multiplications here, then I am going to get which is y3 of t is equal to summation of the two previous outputs. Means if the input is a summation of the two previous inputs, the output has to be the summation of the two previous outputs. So in this case, if the input is a summation of the two previous inputs and the output is the summation of the two previous outputs, then we can say that this is nothing but a linear system. So whenever we are giving for any system the scaled versions of the previous inputs, then the output will be the same scale version of the previous outputs. Suppose, so now we'll check whether this system is a time variant system or time invariant system. So here for the system, the input is x of t and the output is y of t is equal to x of t into cos of 100 pi t. Suppose for this system, suppose if you are going to give an input which is x1 of t is equal to just the time delay of this x of t. So we are going to give a new input which is the delay of the previous input, then the output which we need to get is the delay of the previous output we need to get. Then only we are going to say that system is said to be time invariant system, otherwise it is a time variant system. Suppose if you are giving a new input which is the previous input with some small delay which is t naught, then the output which you are going to get is y1 of t is equal to here in place of x. Suppose the input is x1 of t means x1 of t into cos of 100 pi t, because we are going to change only the input. So in this case we are going to give an input which is a delay of the previous input. So therefore the output which is y1 of t is equal to x of t minus t naught into cos of 100 pi t. Means if this is the input which you are going to give, the output is this is the output which we are going to get actually from this system. But we need to get a output which is y of t minus t naught. Means if the input is delayed, the output also has to be delayed. So therefore y of t minus t naught. So in place of t, I need to substitute t minus t naught. So therefore x of t minus t naught cos 100 into pi of t minus t naught. So this is the equation which we are going to get. So if you compare these two equations are not equal. So therefore we can conclude that this system is a time variant system. Means if you are going to give a delay in input, the same amount of delay has to present in the output. But in the case we are going to get a output which is not equal to the same delay in the input. So therefore we can conclude that the system is said to be a time variant system. Now we are going to check whether the system is a causal system or non-causal system. The causal system means the output of the system must depend upon only on the present input and the past input, but not on the future input. Then the system is said to be the causal system. Means then only we can easily physically reliable, means physically we can build that system. Otherwise only causal systems are physically reliable or physically we can build them, but not the non-causal systems. So here if you see carefully here, the expression is y of t is equal to x of t into cos of 100 pi t. So if you are taking y of 0, then it is also x of 0. If it is y of 1, then x is also x of 1. Means at any time t, the output is depending upon only in the present input. So therefore we can conclude that this system is a causal system. Means this output of system is not depending upon only on any of the future inputs. So therefore we can blindly say this system is a causal system. Means physically we can build this system. So now we are going to check whether this system is a stable system or unstable system. As per the definition of the bibound stability, means bounded input and bound output. So for every bounded input, if the output of the system is bounded, then we are going to say that system is said to be a bibound stable or the stable system. So if for every bounded input, if the output has a bounded value, then we are going to get. So now we are going to solve about the stability of this system. Now we need to check whether the system is a stable system or the unstable system by using the property of the bibound stability. Means for every bounded input, if the output is a bounded, then we are going to say the system is said to be a bibound stability. Means it is a stable system. See, this is the cos. See, y of t is equal to x of t into cos of 100 pi t. So this is the cos function of cos 100 pi t. This is the nature of the cos function. For this cos function, I am going to give x of t as a bounded input. Means here it is going to have a values of +1 and -1. This is a bounded input, means it is not going to have any infinite values. For each and every time there is some finite value of quantity which is defined. So therefore it is not having any unbounded input. So it is a bounded input. So therefore we are going to say we are going to give a bounded input which is peak value of +1 and -1. And if you do the multiplication of these two signals, here the positive region and positive region will become like this, and the negative and negative will become again positive. So therefore this is the waveform we are going to get after doing the multiplication of this x of t and the cos of 100 pi t. So if you see carefully here, the output of the system has a bounded, means here it is not going to have any infinite values. It is going to have some specified values and each and every instant of time. So therefore we can conclude that this is nothing but for every bounded input, if the output is a bounded, we can tell that that system is said to be a stable system. Means this system is nothing but a stable system. Now we are going to check whether this system is a static system or the dynamic system. Static system means it is a memoryless system, and the dynamic system is said to be a memory system. Means here the output, the present output is depending upon only the present input. It is independent of the past inputs. So we can say this system is a static system. Means there is no required of any memory for the past inputs. So therefore here the present output is depending upon only the present input. So therefore this system is a static system. But if in case if the present output depends upon present input and also suppose the past inputs, then that system is said to be the dynamic system or the memory system. But in this case the present output is depending upon purely present input. So therefore we can say this system is a static system or a memoryless system. So finally we can conclude that from the previous analysis we can conclude that the system is a linear system. It is going to satisfy this linearity. So therefore this system is said to be a linear system, and it is a time variant system. Means for delay in for a small change delay in input, the output is not going to have a same delay. It is going to have some variation. So therefore it is a time variant system, and it is also causal system. It is also a stable system, and it is also static system. It means memoryless system. These are the things which you observed from this equation. We are going to solve the 12th question. See the question here. The difference equation y of n is equal to x of n plus 2n into x of n minus 1 corresponds to which of the following? The 1 linear system, 2nd non-linear system, option 3 time invariant system, and 4 time variant system. Select the correct answer using the codes given below. So out of the 4 options, option B is a 1,4 is the correct solution of this question. Means this system is a linear system and also it is a time variant system. So let's solve this numerical. So for this discrete time system, the input and output relation is y of n is equal to x of n plus 2n into x of n minus 1. So for this system we need to figure out whether this system is a linear system or non-linear system or time variant system or time invariant system. We need to check here. So the first property I am going to check is whether this system is a linear system or non-linear system. So for the system, if the input is x1 of n, the output is y1 of n is equal to x1 of n plus 2n into x1 of n minus 1. So for the same system, if the input is x2 of n, the output is y2 of n is equal to x2 of n plus 2n into x2 of n minus 1. See, for the same system, if the input is x3 of n, then the output will be y3 of n is equal to x3 of n plus 2n into x3 of n minus 1. Suppose if this x3 of n is the new input is the summation of the two previous inputs, which is x1 of n plus x2 of n. Let me substitute here x3 of n is equal to x1 of n plus x2 of n in this equation. And if I substitute here in place of x3 of n, x1 of n plus x2 of n, and x3 of n minus 1 means x1 of n minus 1 and x2 of n minus 1. So if you solve this algebraic equation, we are going to get which is the summation of the two previous outputs. So the linear property is always going to say that if the input is the summation of the two previous inputs, then the output has to be summation of the two previous outputs. Then the system is said to be a linear system, otherwise it is a non-linear system. So by this principle we can easily see that if the new input is a summation of the two previous inputs, the output which you are going to get is a summation of the two previous outputs. So therefore we can conclude that this system is a linear system. So now we are going to check the another property, which is whether the system is a time variant system or time invariant system. So for the system, the input is x of n. So therefore the output is y of n is equal to x of n plus 2n into x of n minus 1. So I am going to give for the system the input is x1 of n. So therefore here the output is y1 of n is equal to x1 of n plus 2n into x1 of n minus 1. Suppose if this new input is the delay of the previous input, here x1 of n is equal to x of n minus 1. So wherever the x1 of is 1 is there, we need to substitute this value. So therefore x1 of n means x of n minus n naught, and x1 of n minus 1 means here in place of n substitute n minus 1. So therefore for now here for this small delay in the input, this is the output expression we got. But for a time invariant system, whenever there is a small delay in the input, the same amount of delay has to present in the output. So therefore in place of n, substitute n minus n naught. So therefore x of n minus n naught to 2 of n minus n naught into x of n minus n naught minus 1. So this is the expression we are going to get. And if you see both these expressions, y of n minus n naught and y of 1n are both are not same, means they both are not equal. So therefore we can conclude that whenever there is a change in small delay in input, the same amount of delay is not present in the output. So therefore we can conclude that this system is a time variant system. So finally we can conclude that this system is a linear system and also a time variant system. So now we are going to solve the 13th question. See the question here. The system y of t is equal to t into x of t plus 4 is. So are the four options. Option A, which is the system is a nonlinear system, and also this is time varying system, and also it is a unstable system. So let's solve this numerical. So now we are going to check whether this system is a linear system or non-linear system. See the expression is, the input output expression is y of t is equal to t into x of t plus 4. I already told you for a linear system, whenever the input is 0, the output has to be equal to 0. But here, if whenever x of t is equal to 0, the output is equal to 4, means non-zero value. So therefore we conclude that this system is a non-linear system. But let us do the standard procedure of solving this question. So here for this system, let me assume the input is x1 of t. So therefore the output expression is y1 of t, which is t into x1 of t plus 4. For the same system, if the input is x2 of t, then the output will be y2 of t. The expression of the output is y2 of t is equal to t into x2 of t plus 4. Now for the same system, if the input is x3 of t, then the output expression is y3 of t, which is y3 of t is equal to t into x3 of t plus 4. Now let me assume this new input, which is the summation of the two previous inputs. So therefore wherever the x3 of t has to substitute the summation of the two previous inputs, which is x1 of t and x2 of t. So if you solve this equation, we are going to get in this manner. This is the expression we are going to get. But here for linear system, always whenever the input is a summation of the two previous inputs, the output has to be summation of the two previous outputs. So let me do the summation of the two previous outputs. So y1 of t and y2 of t, if I do the summation, I am going to get in this manner. So if you see carefully, the summation of the two previous outputs is not equal to the y3 of t. So therefore we conclude that this system is said to be a non-linear system. Means whenever we are taking a new input which is summation of the two previous inputs, the output is not equal to the summation of the two previous outputs. So we can blindly say this system is said to be a non-linear system. So now we are going to check whether this system is a time variant system or time invariant system. See for this system, the input is x of t and the output is y of t is equal to t into x of t plus 4. So let me assume a new input which is x1 of t. So therefore the output expression is y1 of t is equal to t into x1 of t plus 4. So for this input, for this new input, if this new input is a small delay in the previous input, which is x of t minus t naught, so wherever x1 of t is there, you need to substitute x of t minus t naught. So therefore we got y1 of t is equal to t into x of t minus t naught plus 4. This is the expression we got. But actually for a linear time in invariant system, always whenever there is a small delay in the input, the same amount of delay has to present in the output also. So therefore wherever t is there, substitute t minus t naught. So therefore t minus t naught into x of t minus t naught plus 4. This is the expression we got for a y of t minus t naught. If you see carefully, here y1 of t is not equal to y of t minus t naught, means whenever there is a small amount of delay in the input, the same amount of delay is not present in the output. So therefore we can conclude that this system is said to be a time variant system. Now we are going to check whether this system is a stable system or unstable system. The expression is y of t is equal to t into x of t plus 4. See, the Bible stability always tells that whenever the input is a bounded input, the output has to be bounded. Then only we are going to say that system is said to be a stable system. Otherwise it is said to be unstable system. So let me assume the input is a bounded input, which is x of t is equal to u of t. So this is the input, means for every time t there is some specific value, means the magnitude has a specific value. So therefore we are going to say this system is a bounded value, bounded input. So the output is y of t is equal to t into inverse of x of t. We need to substitute u of t. So t into u of t plus 4. So now I am going to draw this equation of this line. Y of t is equal to, at y of 0, this is u of t is equal to 0, means at t is equal to 0 into u of t is nothing but 0 plus 4 is equal to 4. So therefore this is the diagram of the y of t expression. So therefore here this is the expression of the y of t. As the time t grows on increases, the output value goes on increases, means there is no finite bounded of the output, means the output value goes on increases, means there is no, so the output is not a bounded output. So therefore we can say that for a bounded input we are going to get an unbounded output, means so we can conclude that this system is said to be an unstable system. So finally we have concluded that this system is a nonlinear system, and the system is also time variant system, and the system is also an unstable system. So now we are going to solve the following question. See the question here. The value of the delta of 2n is equal to. So we need to find the function, the value of the function delta of 2n is equal to. So what are the four options? Option A, which is delta of n. So the delta of 2n is equal to delta of n. So let's solve this numerical. So now we need to check what is the value of the delta of 2n is going to equal to. So let me assume y of n is equal to delta of 2n. So here now let me assume I am going to keep here n is equal to 0. So therefore delta of 2 into 0 is nothing but delta of 0. So the impulse value always is going to have the one value at only 0 position, but remaining all positions it is going to have value of 0. So therefore at delta of 0 it is going to have value of 1. And if you substitute no matter other than 0, always this value will result in a 0 value. So therefore this is the graph of the y of n, which is at n is equal to 0 only we are going to get, which is 1, and remaining all other times it is going to have a 0. So therefore from this clearly we can say that this is nothing but delta of, means y of n is nothing but delta of n. So therefore we can conclude thus delta of 2n is equal to delta of n. So therefore this is the meaning of this one. So here this is for the discrete time system, but for the continuous time system, delta of at is equal to 1 by mod a of delta of t, means if you are doing the scaling operations by a, we are going to get, this is the equation. So similarly for delta of a into t minus t naught, we are going to get the expression which is 1 by mod a into delta of t minus t naught. This is only for the continuous time case. So let me explain why this is also going to be possible. See, suppose let me assume a function p of t. For this function phi of t, let me assume this width is a and minus a, means the width is 2a and the height is 1 by 2a. So therefore the area of this is nothing but length into breadth, which is length is 2a and the breadth is 1 by 2a. So therefore if you do the multiplication, we are going to get area is equal to 1. And if you substitute the limit a tends to 0, this signal is going to give an impulse function, means whenever the limit a tends to 0, this impulse, this rectangular pulse is going to give a signal of shape of delta of t. See, for this p of t, now I am going to do a small scaling operation, p of 2t. So for the p of 2t means now this width size is going to decrease. So for the edges we need to do by the scaling operation. The scaling is 2, so therefore we have to do for the edges by 2. So whatever the value, we have to do the division. So a by 2 minus a by 2. So now the width is only, now the width is only a and the height is 1 by 2a, and if you do the multiplication, length into breadth, a into 1 by 2a is nothing but 1 by 2. So now we are going to get area is equal to 1 by 2 because the length is a and the height is 1 by 2a. So if you do the multiplication, we are going to get area is equal to half. So therefore if I substitute the limit a tends to 0, this p of 2t, now the area is 1 by 2 into delta of t. This is the function I am going to get as an impulse of area 1 by 2. So this is nothing but limit a tends to p of 2t is nothing but delta of 2t. So therefore delta of 2t is equal to 1 by 2 times of delta of t. So this is for the continuous time notation. And suppose if I am going to take here minus 2, suppose if I am going to take here minus 2, then this is the same figure I am going to get, again same figure, but here now I am going to get here 1 by 2. So therefore this is the same thing I am going to get. So delta of minus 2 is equal to 1 by 2 into delta of t. So that is the reason we are going to take here modulus. So here this is for the continuous time case, but for the discrete time case always delta of n is equal to delta of fn. But this is for the continuous time and this is for the discrete time case. Now we are going to solve the 15th question. See the question here. So what is the fundamental frequency of a discrete time square wave shown in the figure? So for this discrete time signal we need to find what is the fundamental frequency. So what are the four options? Option C, which is pi by 4 radians. So the fundamental angular frequency is pi by 4 radians is the correct solution of this question. So let's solve this numerical. So now in this question, for this signal, you need to find what is the fundamental frequency. So if you see carefully here, there are actually time period of discrete signal is nothing but the number of pulses which are going to repeat itself. If you see carefully, this 1, 2, 3, 4, 5, 6, 7, 8. After this 8 pulses, the same figure is going to repeat, and then the same figure is going to repeat. So therefore, these are the 8 pulses, which is 1, 2, 3, 4, 5, 6, 7, 8. So the number of pulses which are going to repeat itself is nothing but 8. So therefore, for this system, for this discrete time system, the time period is nothing but the number of pulses which are going to repeat, which is n is equal to 8, and n is the, so therefore the fundamental frequency is 2 pi by n. 2 pi by n is the fundamental frequency. So therefore 2 pi by n is nothing but 8. So therefore if you solve this one, we are going to get pi by 4. So therefore the fundamental frequency of this signal is pi by 4 radians. And some more extra concept here, for discrete time system always for omega naught and omega plus 2 pi and omega naught plus 4 pi up to omega naught plus 2 pi k, where k is the integer, means all these waveforms, all these signals are going to have a same figure. May suppose this is the figure for omega naught, then with the frequency of omega naught plus 2 pi, same figure is going to repeat, and similarly for omega naught plus 4 pi also the same figure is going to repeat. But finally for general expression is omega naught plus 2 pi k, where k is the integer. So finally what I am trying to say is, for all these different frequencies in discrete time system, the amount of figure, the graph shown is always going to be same for all these systems. For the continuous time system, all these different frequencies have different waveforms, but for the discrete time system, all these with a range of, with a phase difference of 2 pi, all these signals will have same amount of figure. So now we are going to solve the 16th question. See the question here. Assertion is going to say that if two signals are orthogonal, they are also orthonormal, and reason is going to say like this: if the two signals are orthonormal, they are also the orthogonal. So are the four options? Option D is the correct solution of this question, means assertion is wrong and the reason is the correct solution of this question. So let's solve this numerical. So let me explain a small concept regarding the vectors here. See, for orthogonal vectors means when the dot product of the two vectors is 0 and the length of each vector is non-zero, means the length can be either 1, either the length of the vectors can be 1, 2, 3 or up to infinity. So except 0, the length can be anything. This is the property of the orthogonal vectors. But for the orthonormal vectors, the dot product of the two vectors has to be equal to 0 and the length of each vector has to be unity. So therefore, the length of the vector has to be compulsory unity, but in the orthogonal, the length of the vector can be any value except 0. So therefore, we can conclude that all the orthonormal signals are orthogonal, but all the orthogonal signals are not orthonormal. Means here 1 is going to present, the length is 1, so here also the length is 1, but length 2 is not present in the orthonormal. But so therefore all the orthonormal signals are orthogonal, but all the orthogonal are not the orthonormal. That is the concept here. But for signal and system, the orthogonal property is integration 0 to t f1 of t into f2 of t is equal to 0. This is the meaning of the orthogonal property for the signals. This is for the vectors. So finally what I am trying to say is, here all the orthonormal signals or vectors are the orthogonal, but all the orthogonal signals are not the orthonormal. So therefore the assertion is wrong and the reason is the correct solution of this question. So now we are going to solve the 17th question. See the question here. So what is the input-output relation of the causal moving average system? So what are the four options? Option A is the correct solution of this question. So in this question they are asking what is the input-output relation of the causal moving average system. So what are the four options? Option A is the correct solution of this question. So let's solve this numerical. So now from these options we need to check what is the input-output relation of the causal moving average system. for a discrete time system. See, if you see carefully, for causal property we need to check the first property we are going to check is the causal. So here for option B, if y of 0, if n is equal to 0, is going to depend upon the future input. So therefore y of 0 is depending upon the x of 1 future input. So we can say this is nothing but a non-causal system. So B is not the correct answer. And similarly for D also, y of 0 is going to depend upon x of 1 and x of 2, means it is also depending upon the future input. So therefore this is a non-causal system. And if you take the first and the A and C, if you see carefully, there is a square, there is a 1 by 2, and here it is going to depend upon the past input values. So moving average means it is going to take even the past values, but here it is going to take only the present values. So therefore this is not the correct. So therefore finally this is the correct solution of this question, because moving average means we are going to consider even the past values of the input. So therefore only this is the option is going to show you the past values, which is x of n minus 1 and x of minus 2, present x minus 1 and x minus 2, and do the summation by take the average 3. So this is the correct solution of this question. So now we are going to solve the 18th question. See the question here. Which one of the following pairs is not correctly matched? So here A, B, C, D, out of this they are given the equations also. So which one of them is not correctly matched? So option B is not going to correctly match. So therefore y is equal to 3x plus 2 is nothing but a non-linear system. So let's solve each and every one, and let's figure out whether these are the causal, linear, stable or time invariant. So now let us solve each and everything options, and let us figure out which one is the incorrect one. So option A, they are going to given us it's a causal system, y of n is equal to x of n minus 1. So we need to figure out whether this is a causal or non-causal. So if you substitute n is equal to minus 1, we are going to get here x of minus 2, and if I substitute y of 0, I am going to get here x of minus 1, and if I substitute y of 1, I am going to get here x of 0. From this we can conclude that the present input depending upon the past input but not on the future input. So therefore whenever any output is independent of the future input, then we can say that system is said to be a causal system. So therefore this is a correct one. So but here for the option B, they are given this is a linear, y of n is equal to 3x plus 2. Whenever I have told you, whenever the input is 0, the output has to be equal to 0. But here whenever the input x of n is equal to 0, we are going to get output is equal to 2, which is a non-zero value. So therefore we can conclude that this system is a non-linear system. So in the question they asked which one is the incorrect one. So therefore B is the incorrect one. So let us solve this also by the standard equation, so let us also solve this by the standard procedure, which is suppose for the input x1 of n, the output is y1 of n. For the input x2 of n, the output is y2 of n. Suppose for the input x3 of n, the output is y3 of n. Let me assume the new input is the x3 of n is the sum of the two past inputs. So therefore x1 of plus x2. So if you do this summation, it is not equal to the summation of the two previous outputs. So we can conclude that this is the non-linear system. So in the options they are given it is a stable system. The input output relation is y of n is equal to xn plus 5 into x of n minus 1. So the bibo stability is going to tell you that whenever for a bounded input, the output has to be a bounded output. So let me take a small input which is bounded input. This is x of n is equal to u of n, and let me the output y of n is equal to, in place of x of n I need to substitute u of n. So 2u of n plus 5 into u of n minus 1. So this is the input which is x of n is equal to u of n. This is the, for t less than 0 it is 0, for t greater than 1 the value of is 1. But for the figure output y1 of n, y of n, this is the figure which is for t less than 0 it is 0, for 0 to 1 the value is 2, from 1 to infinity the value is 7, means it is going to have some finite value at each and every instant. So therefore it is not going to have any infinity value. That is the reason it is going to have a bounded output. So therefore for a bounded input we are going to get a bounded output. So therefore this system is said to be a stable system. So let us solve the fourth one also. For the D case, they are given that system input output relation, this system is they are given it as a time variant. We need to check whether this is a time variant or not. See, for a given system, if the input is x of n, the output is here y of n is equal to x of n plus 2n into x of n minus 1. So for this same system I am going to give a new input which is x1 of n. So therefore the output is y1 of n is equal to x1 of n plus 2n into x1 of n minus 1. So now this new input is a delay of the previous input which is x of n minus n naught. So wherever x1 of n, I need to substitute x of n minus n naught. So therefore y1 of n is equal to in place of x1 of n, I am going to substitute x of n minus n naught and 2 plus 2n x of n minus n naught minus 1. This is the output I am going to get. But actually for a time invariant system, whenever there is a small delay in the input, the same amount of delay has to present in the output also, means y of n minus n naught. So therefore here in place of n, I need to substitute n minus n naught. So therefore x of n minus n naught plus 2 in place of n minus n naught, and similarly here also n minus n naught minus 1. So if you see carefully, this y of n minus n naught and y1 of n are not equal. So therefore we can conclude that this is time variant system, means whenever there is a small delay in the input, the same amount of delay is not present in the output. So we can conclude that this system is said to be a time variant system. So now we are going to solve the 19th question. See the question here. What type of system the difference equation y of n is equal to x of n plus x of n minus 2 represents? So for this equation we need to find whether the system is a linearity or time variant or not. So from these options, option C, this system is a nonlinear system and also this is a time invariant system. So let's solve this numerical. So now for this system, the input output relation is given in the question. So for this system we need to check whether this is linear or not. See, blindly from this equation there is a constant term. Whenever there is a constant term in any equation, we are going to say that system is said to be a non-linear system. Means whenever the input is 0, still there is an output value. So it means it is a non-linear system. Let us always do by the standard procedure, which is for the system, if the input is x1 of n, then the output is y1 of n is equal to x1 of plus x1 of n minus 2 minus 2. And similarly for the same system, if the input is x2 of n, so therefore the output is y2 of n is equal to x2 of n plus x2 of n minus 2 minus 2. For the same system, if the input is x3 of n, now output is y3 of n is equal to x3 of n plus x3 of n minus 2 minus 2. So let me assume the new input x3 of n is the summation of the two previous inputs, which is x1 of n plus x2 of n. So wherever x3 of n is there, substitute this summation. So x1 of n plus x2 of n. Similarly here, x1 of n minus 2 plus x2 of n minus 2 minus 2. So if you do this one, if you simplify this one, it is not going to equal to summation of the two previous outputs. Means if the new input is a summation of the two previous inputs, still the output is not the summation of the two previous outputs. So we can blindly say this system is said to be a non-linear system. So now we are going to check whether this system is a time invariant or time variant system. See, for this system, if the input is x of n, the output is y of n is equal to x of n plus x of n minus 2 minus 2. For the same system, if the input is x1 of n, then the output is y1 of n is equal to x1 of n plus x1 of n minus 2 minus 2. See, if the new input is a delay of the previous input, which is x of n minus n naught, so wherever x1 of n is there, substitute x of n minus n naught. So therefore x1 of n is x of n minus n naught, and x1 of n minus 2 means here n minus n naught minus 2. So therefore this is the thing we are going to get here. Actually it is n minus 2 minus n naught. This is what we are going to get here, because n minus 2 we are going to replace n by n minus 2. So this is the thing we are going to get minus 2. See, for this time invariant system, whenever there is a small change in the input, small delay in the input, the same amount of delay has to present in the output also. So therefore wherever n is there, substitute n minus n naught. So therefore x of n minus n naught, x of n minus n naught minus 2 minus 2. So if you see clearly, both are same. So therefore we can conclude that y of n minus n naught is equal to y1 of n. Means whenever there is a small change, small delay in the input, same amount of delay is also present in the output. So we can conclude that the system is said to be a time invariant system. So now we are going to solve the last question of this lecture, the question number 20. See the question here. The impulse response of a linear time invariant system is given by h of t is equal to 2 into e to the power of minus t u of t. So the unit step response is given by. So in the question they are given the impulse response. We need to find what is the step response. So what are the four options? Option A is the correct solution of this question. So let's solve this numerical. So in the question they are given, for this LTI system, if the input is impulse signal, the output is going to be impulse response. They are given the equation which is 2 into e to the power of minus t u of t. See, for the same LTI system, if the input is unit step input, then what is the unit step response? S of t we need to figure out. See, we know the basic relation between the unit step signal and the impulse response. Impulse signal, unit step signal and the impulse signal is u of t is nothing but the integration of the impulse signal. So impulse signal is the integration, we are going to get the unit step signal. In the same fashion, its output is also going to have the same relation. If you give the u of t as an input, the output we are going to get step response S of t, and similarly if you are giving input delta of t, the output will be h of t. So inputs have same relation and the output will also have the same relation, which is S of t is equal to integration of minus infinity to t h of delta d delta. Means we are going to do the integration. So therefore here h of tau is t, so wherever t is there, substitute tau. So therefore 2 into e to the power of minus tau u u tau d tau. See here, u of tau is always 0 for t less than 0. So therefore here s of t is equal to 0 for t less than or equal to 0, because here u of tau is going to have only signal for tau greater than 0 but not for less than 0. So therefore s of t is equal to 0 for t less than or equal to 0. But for s of t for t greater than or equal to 0, so this minus infinity is going to go to 0, because here for minus infinity to 0 the integration will become 0. From 0 to 2 only this value will be present. So therefore 0 to t 2 into e to the power of minus tau d tau. So now I am going to do the integration here. 2 into e to the power of minus tau integration is e to the power of minus tau by minus 1. Now I am going to substitute the limits 0 to t. So this is minus 1 goes to this side. So for minus 2 into e to the power of minus t minus 1. So minus I am going to take it inside. So therefore 2 into 1 minus e to the power of minus t. This is for t greater than or equal to 0. So s of t is equal to 0 for t less than or equal to 0, and s of t is equal to 2 into 1 minus e to the power of minus t for t greater than or equal to 0. So therefore finally we are going to combine these two results, and simply we are going to write here s of t is equal to 2 into 1 minus e to the power of minus t into u of t. Means for t less than 0 this u of t is equal to 0. So therefore the step response is equal to 0, and similarly for t greater than or equal to 0 this u of t is equal to 1. So therefore s of t has a non-zero value. So by this lecture we have successfully completed the 20 questions which are the previous year UPSC civil service questions of the signal and systems in a very detailed manner. If you like the content of our channel, then please do like, share and subscribe our YouTube channel, and don't forget to press the bell icon button so whenever you upload a new video the direct notifications comes to mobile. If any improvements needed in the video lectures, then please do comment in the comment section. We will definitely include all those improvements in the coming lectures. Thank you so much for watching this lecture. Keep smiling, take care and bye bye.